Hello, Riles. For lesson 1.7, I'd like to go into some more algebraic examples of using function notation. So, one of the things that I'm trying to do right now, I suppose, is sell you on this new notation to try to convince you that it's actually useful. And we'll definitely see how it's going to be useful later in the course, but for now, I need to try to convince you the fact. So let's say if h of x equals 2x minus 1, let's simplify the expression h of c plus d minus h of c all over c plus d minus c. Sometimes I have students calculate this and then we discuss why the number is the way that it is. But I think this time I want to point out to you what we're able to do with function notation without introducing too many more symbols. If you understand that this relationship here is a function, it can be represented by a graph, then what I have here is some output from an input of c plus d, and then some output from an input of c. So imagine somewhere on this graph you have the ordered pair c comma h of c. Do you notice how even though h of c is a separate unknown, it's a separate variable, it is an output, I can write this without labeling it x comma y. Why would labeling it x comma y cause problems? Well, how about if I have some second point here that is d forward from c? Let's call its input c plus d. Its output is going to be given by the output from the machine h when the input is c plus d. That can be labeled h of c plus d. You might start to recognize this as a familiar formula. Excuse me. What I'm looking at is the difference in outputs divided by difference in inputs, or a second y value minus a first y value divided by some second x value by some first x value. This should give me the rate of change between any 2 points on this relationship. And if you identify this as being a constant linear relationship, a linear relationship whose rate of change is constant, you're not going to be surprised that the value of this is actually going to be 2. We're told to simplify. Turns out we can't actually evaluate this. And I'm wondering if we can start to see some advantages here. The slope formula has like 1, 2, 3, 4, 5 different unknowns. You have to use subscripts to say, oh, this is the y value that corresponds with the second x value. This is the y value that corresponds with the first x value. You can make use of those inputs again. You call this x1, c is x1, h of c is y1. You call c plus d x2, then h of c plus d is going to be y2. Right. I know it's a tough sell right now, but um, you'll discover how the function notation isn't that difficult and can be useful. Okay, let's try running this notation with more complicated algebraic inputs. If h of x is the double of x minus 1, 1 less than the double of x, you could read it as h of bracket is 2 times bracket minus 1. H of something is 2 times something minus 1. That means that h of c plus d is going to be 2 times c plus d minus 1. Often what students will say is, oh, you're just saying that x is c plus d. You just need to be careful there because we should be able to evaluate h of x plus 1. And saying something like x is x plus 1 can cause problems. If I run the h machine on an input of c, that machine is going to double c and then subtract 1. And then in this expression, I want to subtract that output from this first input. Notice my use of secondary brackets here because I need to subtract a polynomial expression. I want to subtract 2 times c minus 1. This is not the first time it's happened in this course. In the denominator, c plus d minus c, the brackets are really just to sort of visualize the idea of a y2 and a x2, a y1 and an x1. C plus d minus c is going to be d. That's really my run here, isn't it? The distance from c to c plus d is just d. What I'm simplifying in the numerator is my rise. I'm going to use the distributive property of multiplication through sums and differences here to get 2c plus 2d minus 1. I think I'll do 2 times c and distribute the multiplication of negative 1 through here to get minus 2c plus 1 all over d. See if you can follow that algebra. Generally a good idea not to perform two different levels of arithmetic on the same line. For example, I'm going to do 2c minus 2c is 0, and -1 plus 1 is 0. But then I'm not in a rush to divide these d's. I want to show my reader that there is a factor of d. And then 2d divided by d, like a rational expression, is almost always going to equal 2. The only restriction here is that d can't equal 0. A grade 9 student would tell you can't calculate a slope where your run is 0. You need to choose two different points on a line to calculate a slope. You can't find the slope from this point to that point. You'll get 0 divided by 0. And that's what we would have here. 2 times 0 divided by 0 isn't going to be 2. So the conclusion that we draw is that this is proven that it doesn't matter what 2 points you go in between, your slope, your delta y over delta x for this relationship will always equal 2. You'll see plenty of first differences and second differences in your homework for lesson 1.7. So don't be surprised if you get a lot of the same number over and over again. Okay. While we're still here, let's just cover this idea that a new x could replace an old x. Let's just simplify. H of, how about 2x plus, you know what, this might actually be interesting. Because h of x is 2x plus 1. Now I want to evaluate h of 2x plus 1. It's kind of like evaluating h of x. That's why it's called recursion. I run a machine on itself, kind of thing. This is where I don't think you want to say, oh, so you're saying that x is 2x plus 1. You might find it better to read this as h of input is the double of the input minus 1. So run the h machine on this input. You're going to double that input and then, subtract 1. Yeah, I guess I'll just change this. There we go. Double that input and then subtract 1. Call it h of bracket is 2 times bracket minus 1. Well, what's in the bracket? 2 times x minus 1. And now you just simplify. You'll get 4x minus 2 minus 1, which is 4x minus 3. And that's it. Okay. You just imagine replacing what's inside that bracket with what's inside this bracket. See if you can do that without saying x is 2x minus 1, because that's not true. Give it a shot.